Hello and welcome everyone to my channel Code with Ease by Varsha. So today we will discuss about the second design pattern. We have already covered builder design pattern in the earlier video. Today we will talk about the factory method design pattern. So let's see what all we are going to cover as part of today's session. We are going to begin with a real world problem. Then we'll see the existing code of that problem. And then what are the problems we are facing with the code. Then we'll talk about what is factory method design pattern. What can be the optimized code by applying the factory design pattern to the existing code that we have seen. Then what problem the factory method design pattern is trying to solve using an example. Then we are also going to compare the three types of factory pattern, that is simple factory, factory method and abstract factory. We'll also see the code for three of them. And then we'll discuss a few real world use cases of where the factory design pattern can be used. And we'll have some sample problem statements at the end which you can use to practice this pattern, and we'll have a small quiz at the end to evaluate how much you have understood from this session. I would recommend to take notes while you watch this session because there is going to be theoretical concepts also which I'll put up on each of the slides, which you can take it down, and then it will be more interesting to watch the entire session also, and it will keep you hooked until the end. And of course then you can take the quiz at the end to evaluate whatever concepts you have understood or not understood. I think that is the best way to study. So now without further delay, let's start. So starting with the first real world problem. So let's say you are at an ice cream store. We know that ice creams are manufactured at factories. Okay, so the reason why we call this design pattern a factory design pattern is it is something related to the procedure that happens at a factory. What does a factory do? Factory helps to manufacture goods, products, right? So similar to this example, now when we talk of ice creams, when we go to a store, we see there are so many different flavors of ice cream that is available. But you see, essentially, the process of making an ice cream, which happens at the factory, is pretty much standardized. Okay, there is a standard procedure of they mix all of the ingredients, then they freeze it, they put it into containers. So pretty much the same process is being followed, irrespective of what flavor you are having the ice cream of. So this is the problem that we are starting with. So if I have to write the code for this, that I am at an ice cream store, there are different flavors of ice cream. So how do I write the code? Let's see. Let's go to the IDE and see the code for this. Okay, so now let's take a look at the existing code. So now we want to create ice cream objects. So obviously we would have a class. Again, I'm talking in terms of Java programming language because that is the language we're going to use throughout the series. And of course, we'll talk in terms of object-oriented paradigm. Hence, we'll mention a lot about classes and objects. So we have an ice cream class to represent the ice cream objects. It's a plain and simple class. It's a POJO, will have all the characteristics that an ice cream can have, the flavor, the toppings, whether it will be served in a cone or a cup. And then we are going to have the different methods. So now if I want to go to the main class, which is going to act as a client code or the actual ice cream store class. So in this, I want to create a ice cream object. So what will I do? So I'll just write ice cream, and then let's say I want to initially create a vanilla cup. I want to create new ice cream, and then I'll just say the flavor is vanilla. I want the toppings of fresh fruits, and I'll say I don't want to serve in a cone, so I'll just put is cone is false. Now I want to print this object. So what will I? So I'll put vanilla cup, and then whatever the flavor is of this, get the flavor, and then it is served with whatever the toppings we are putting, vanilla cup dot get toppings, and then we will say it is served in a cup. So I'll just print it out. It's served in a cup. Okay. Okay, so now let's discuss what are the problems with this code. What are the problems? Number one is there is high coupling. What it means? Your main class, that is this, is tightly linked with your ice cream class that you have. Okay. So if anything in that changes, if I want to add or remove flavors, it's not like I will always serve vanilla at my store. If tomorrow I don't want to serve vanilla and I want to serve another flavor, everything that I've written in this main class will change with regard to vanilla. So I have to change my client class or the main class because there is a change in the ice cream product. Okay, so that is what is meant by coupling. The another problem that we can see is there's a lot of duplication. Like if I'm creating a vanilla cup in this way, tomorrow if I want to now if I'm creating like this, now if I want to, let's say, create a chocolate cone, I want to create ice cream with chocolate cone. So I'll again call the constructor, I'll put chocolate, and then I'll just say put some brownie toppings and put it in a cone, so is cone will be true, and then again I'm going to print it out. So basically the more and more objects I'm trying to create, it is going to duplicate the same code again and again. Third thing, what is going to be problem is the inflexible. So if I want to change anything in my ice cream class, there is no independence. If I'm changing my object, the ice cream object, I have to touch the main class, the main method. So if, let's say, if I talk of an example in the factory, if tomorrow there is any process change, in the ice cream object. So that will also get reflected here, because the constructor that we are using to create the object only is very much hard coded over here. If tomorrow some process changes, I have to change again in the client code. So this is the third limitation of this. So that is what I've written on the problem slide also, that we are directly trying to invoke the constructor, which can work for small number of objects, but as and when we increase, as and when the flavors and the other options grows, it is going to be difficult to maintain. The code is going to have high coupling. The code is having high coupling also. It's tightly linked. We cannot add or remove flavors so easily without having to change the main class. Then there is repeated code duplication, which is reducing the maintainability of the code. And it is not very flexible, because tomorrow if I want to change the creation process, add another step, means I have to again change the constructor. If I'm changing the constructor, all the constructors of the main class will have to be changed. So now we will talk about what exactly is factory method design pattern. We'll introduce this. First of all, it is a creational pattern. Builder pattern, which we discussed, was also a creational pattern. Anything which is a creational pattern deals with the creation of object. Okay. Then it helps us to create objects without specifying the exact class. So this is important. I want to create ice cream, so I don't have to specify the ice cream class. I don't have to hard code the ice cream class. Why? Why is this important? Because tomorrow if I want to change anything in the ice cream class, my main method, the main class should not get affected. When I say main class, the client code, it should not have any effect. I don't have to change anything in the client code just because the exact class, the product class, is being changed. Then it will define an interface, and the specific object will be determined at the runtime by the concrete implementation. So that is a technical thing. And then it is used in situation where, of course, like we told, the client code doesn't have to know how the object is being created. Okay, you go to a ice cream parlor. Is the ice cream parlor concerned how the ice cream is created? No, right? It is not concerned about manufacturing the ice cream. It is not creating you the and giving you the ice cream then and there. That is the work of the factory. The store is not responsible to create the ice cream, right? So that is what this entire design pattern is going to be about. So let's try to understand how does factory pattern help us in solving the problems that we have just now seen. Firstly, it is going to help us to centralize the object creation. So this is the main point, that the object creation that is going to happen now, it will not be happening in the client code, but it will happen in a centralized place. And then by using the factory method or the abstract factory interface, what we can do is we can do a separation of concern, that the client code did not know which specific class of the object needs to be called to create that product. Now the client code need not be bothered about which specific class or like the product class has to be called. What it can do is, instead of that, in between there will be a factory class now. That factory class is going to centralize the object creation. So now the client code will only interact with the factory class, and a factory class in turn will deal with the actual class which is going to give us the product. Okay, so let's see that in action. Let's move to the IDE. We'll discuss the simple factory first. So this is the ice cream class that we have seen earlier, and then this is the main method, and this is the client code where all the ice cream objects are being created. So what we discussed in the previous slide, now we will try to centralize the object creation. So for that, what we have to do is we have to introduce another class in between. I'm going to call this the ice cream factory class. So this factory will be concerned about manufacturing the ice creams. So for that, what we'll do is we'll first say what ice cream has to be returned. So this factory is going to produce the ice cream. So we have to return an ice cream. So initially I'll initialize this to null, and then I'll have a static method. Why I'm going to have a static method? Because I don't have to create an object of the factory class. Okay, I am just going to directly invoke the factory class as and when needed. And this is going to return ice cream. And then I'll just call this create ice cream or manufacture ice cream or produce ice cream. You can name it according to your wish. And then I'm going to pass in the parameters like the flavor, the toppings, and the boolean value that whether it will be served in a cone or not. Now inside this, what will happen? I'll just do a if condition first, that if the flavor is equal to vanilla. Okay, so now if that's the case, what am I going to do? I have to return a new class which is what I'll call vanilla ice cream. Okay, I haven't created the classes or no, but I just wanted to show the flow first, that if it is equal to vanilla, I'll call the vanilla ice cream class. Else if, let's say, if the flavor is equal to chocolate, then I'm going to return new chocolate ice cream. Okay, so why am I doing this? By doing this, I am ensuring anything if changes in future, if the flavors need to be added, I only have to modify the factory class. If the flavors have to be removed, I only have to modify the factory class. As and when needed, I can just do that. So factory class in here is acting as the centralized location which is concerned with manufacturing the ice creams. So now let's try to create this ice cream classes. Of course, these are going to be the subclasses of the ice cream that we have created. First, let's create the vanilla ice cream class. So we have said that it is going to extend the actual ice cream class that we have seen. So this constructor will be called. Now this constructor, we know that whenever a constructor is being called for a class, the first line is the super call. Super call means the call to the parent class. Parent class is ice cream, where it is going to initialize all the flavors, toppings and whatever. Now we already know that it is a vanilla ice cream, so I don't have to pass in the flavor as a variable. I can simply say it is going to be the vanilla flavor only. Toppings can change as and when whatever the object will be created. I can give the toppings whatever I wish to, and this value is also going to be dynamic. So that's it. This is simple, my vanilla ice cream class. Similarly, I'm going to go to the chocolate ice cream and I'm going to create this class as well. So chocolate ice cream, and then over here I'm just going to pass in the flavor as chocolate. That's it. Cool. Now what I have to do is, now back to the ice cream class. So I've given two conditions, like as of now let's have only two flavors, and in the else block I'll say if it's not a matching flavor, I'll just throw a illegal argument exception, invalid flavor, and just print out the flavor. Okay, and now since this is a static method, if I have to return this particular ice cream object, I also have to define this as static. So I'll just call this as a static variable, and now I can say instead of returning from here, I'll just initialize the value over here, ice cream equal to this, or over here ice cream equal to the new chocolate ice cream, and finally from this method I will return whatever ice cream I want. So this is what my factory class is going to look like, where all the object creation is happening inside this, no headache on the client code. Now how the client code will be modified over here. So now I want to create the same drill, like I will create a vanilla cup only. So what I'll do, so vanilla cup I'm creating, I'll now call the ice cream factory class because it was a static method, and I'll just say create ice cream, and I'll pass in the parameters over here. Like here I can say nuts will be the toppings, and now I don't want a cone obviously. And then I'll just copy the same print statement and pass it in. I'll just comment out the previous lines of code of the existing. Now let's run this. So we are seeing that the output is the same, vanilla with nuts in a cup. Just that now I don't have to do new ice cream. I don't have to deal with the original ice cream class at all. I can only deal with the factory class, and the factory class is going to take care of which class it has to call. I'll similarly do a chocolate cone ice cream over here, and dot create ice cream, and then I'm going to pass in the flavor, and then I'm going to say chocolate toppings will be some chocolate syrup, and in this case it will be served in a cone. I'm just going to print this out, chocolate cone. I'm going to change the variables in a cone. Let's run this now. So it's saying that in a cone. So it's saying chocolate with chocolate syrup in it. Essentially, the output is going to be the same because this is the ice cream store which is going to give me the ice cream. Okay, but then the main difference is we are now not dealing with the original class, the exact class which is producing the ice creams. The client code doesn't know whether the vanilla ice cream class is called or the chocolate ice cream class is called. It doesn't. So this is all about the implementation of the simple factory pattern. So what are the problems this optimized code is trying to solve? Like we told, it is trying to centralize the object creation. The creation of the object and the usage of the object are now separated. They're decoupled. Then by using this pattern, like we said that we are trying to create objects in a centralized location. What is that centralized location? That factory class, which is trying to manage the creation of the ice creams or the objects. And then it is also trying to reduce code duplication because of that. And the most important thing, technically what is happening is we're introducing one layer of abstraction between the original product class where the object is being created and the client code. What is the abstraction layer? That factory class. It is adding one layer of abstraction because it is simple factory pattern. That is why it is one layer of abstraction. As and when we increase as and when we see the other types, we'll see there are increased level of abstractions in between. So because of this reason, it is easier for us to change whatever object is being created. Like I told, if I can add and remove flavors, I can modify the objects also, but it is not going to affect my main class, because the main class is only talking to the factory class and not to the original vanilla ice cream class, not to the original chocolate ice cream class, or even not to the base class of ice cream. Okay. Next, what are the types? Like we mentioned, we have just now discussed about the optimized code using simple factory. There are other two types, factory method and abstract factory, which are going to increase the levels of abstraction. So what are those? Simple factory, like it's a basic way of creating the objects, like we have just seen, by introducing one factory class in between. If I have to use factory method class, then what I have to do is I have to add a layer of abstraction. In Java, we achieve abstraction using abstract classes and interfaces. So we'll try to create an interface. We'll see the code just now, how we are doing it. So in factory method, we're trying to add more abstraction by allowing we're trying to add more abstraction by allowing the subclasses to decide which class to instantiate. And in abstract factory, it is giving you the highest level abstraction. So it is now trying to create family of related objects. Okay, so it can be understood in as simple as, if I have to create vanilla ice cream, so let's say there is a different factory altogether for vanilla ice cream only. So anything related to vanilla ice cream, be it the flavors of the flavor is going to be constant, but be it the toppings of the vanilla ice cream or the types of cone which the vanilla ice cream can be provided, it will become one family. The family of vanilla ice cream will be in one factory. The family of chocolate ice cream will be in another factory. So that can be achieved by using the abstract factory pattern. So now let's see the code for the factory method. So in the interest of time, I have just given the code snippets by just reformatting it in a bit. Let's try to understand what we are trying to do in factory method, how the second layer of abstraction is being achieved over here. As we can see, we used an interface called the ice cream factory. Now, ice cream factory earlier was a class. Now we are using an interface, and in that we are creating one abstract method called create ice cream. Now, as and when the different factory classes are going to, like the concrete factory classes are going to implement that interface, they will add their own implementation. But what is that implementation is going to be? If I am a vanilla factory class, I am going to return the vanilla ice cream. If I am a chocolate ice cream factory, I am going to return chocolate ice cream, and same for strawberry ice cream. So now not only the products are separate, even the factory classes are separate. So this is why we are saying second layer of abstraction. If you see right side in the main class, what is happening over here? We are creating the separate classes for the factory classes, the concrete implementation of the factory classes. And then when I have to create vanilla ice cream, I'm calling that factory classes method create ice cream. Okay, so how it is helping us to solve the previous problems that I have seen, we have seen earlier. Instead of now giving the responsibility to the entire factory, one single factory class, I'm distributing the load amongst different factory classes so that there is even more flexibility. If tomorrow something has to be dealt specially for the chocolate ice cream, that can be dealt by the chocolate ice cream factory. The code of the original ice cream factory did not be touched. That is why we have done more separation of concern by distributing the creation of ice cream based on flavors in different factory classes. So this is all about the factory method implementation. So now let's see the code for the abstract factory. So just a small disclaimer, this code is going to be a little bit lengthy. I've divided it in 3 different pages. So first let's see what is the hierarchy of this abstract factory. First of all, if I zoom in, I have an interface called ice cream factory. So I have ice cream factory as an interface. So earlier we had the factory class as a class, and now it is of interface, which means now there will be concrete classes that will be implementing this. And that is what is happening. We have a vanilla ice cream factory, then we have a chocolate ice cream factory, and then we have strawberry ice cream factory. So it is divided in 3 different concrete classes. One is strawberry, one is vanilla, one is chocolate. So 3 different ice cream factories, the concrete classes have implemented the ice cream factory interface. Why we are doing this? To add a different layer of abstraction. So far in the factory method, we have seen that we added only one layer of abstraction by creating the interface of ice cream factory and the concrete classes, but in there we only had one method that was being overridden, like that is the create ice cream. So this was adding one layer of abstraction. If you notice in this class, here also we are providing the create ice cream method, the abstract method. Apart from that, we are also providing a different abstract method for creating the topping. So topping, which we were earlier passing in as a string, now we are creating a separate interface of topping itself, which we will see in the further slides. And then we are trying to create an abstract method of that, which means now vanilla ice cream factory will give its own topping, chocolate ice cream factory will again give its own topping, and strawberry ice cream factory will give its own topping. So not just the create ice cream method has to be overridden in all the concrete classes, even the topping will now be overridden. So now that is why we are saying it is an extra layer of abstraction that we have added. So this much is clear, that the ice cream factory is having, it's again divided into 3 concrete classes, and we have two different abstractions, that is one for the topping and one for creating the ice cream. So let's move on to the next code. Now we have an interface for ice creams. Notice the difference over here. Earlier we had only ice cream class, and now this ice cream has become an interface. Now when this becomes an interface, what is happening is, again, it is divided into concrete classes, means the concrete classes are going to implement those. Vanilla ice cream will implement, chocolate ice cream will implement, strawberry ice cream will implement. What they will implement? They'll implement the make method. So when vanilla ice cream is implementing the ice cream interface, it is overriding the make method and saying, I am making vanilla ice cream, or I am making chocolate ice cream, or I am making strawberry ice cream, whatever it is. The make method is overridden. So very obviously this might come to the mind why we are doing this, why the ice cream class cannot stay as a class and why it needs to be an interface. Because the ice cream class earlier was having three things: the flavors, the toppings, and the is cone property. If we keep the is cone property aside, flavors and topping. Now flavors we have anyway divided and segregated into separate classes over here. So that makes it easier for us. I don't have to provide, I don't have to keep a constructor for initializing the flavor. So that is one problem solved. Secondly, I don't have to pass the topping as a string anymore. I am creating a different interface for topping, which we are seeing in the next slide. So in this way, I have done two level of abstraction. One I did for the ice cream factory. I again did the abstraction on the ice cream class itself. I have converted that into an interface. So one interface is ice cream factory. Second interface is the ice cream itself. Now if we see the third class, which is the third interface, that is topping. So topping, earlier we were passing in the string, we were hard coding the string, but now we will have an interface, a proper topping interface. Again, this will have its own concrete classes, because toppings can be of various type. Like you can see on the screen, hot fudge, sprinkles. Now when I'm creating a vanilla ice cream class, I can add hot fudge also to it, or I can add sprinkles to it. I don't have to care about that. So if I have a generic interface for topping and let the other classes implement it, so I can keep on adding my new toppings each and every day and let it implement and override this add method. Simple. I don't have to maintain any, I don't have to pass the topping every time I'm creating the ice cream object. So three levels of abstraction we have achieved. One is the ice cream factory. Ice cream factory is divided into concrete classes of separate factory class: vanilla, chocolate, ice cream, number one. Number two, ice cream class itself, which is again divided into vanilla ice cream class, strawberry ice cream class, and chocolate ice cream. And thirdly, the third abstraction is topping. The topping also we have divided. So not just the flavor, we have also now created an interface for the topping, and separate toppings can now be implementing the method which is there in the topping interface and add its own implementation. Now finally putting it all together. So this is the main class. Now how we are using it. So you see we are creating three different objects. One for the vanilla factory, one for chocolate factory, and strawberry factory. After that we are now saying vanilla factory dot create ice cream. So create ice cream, which is vanilla ice cream, and then vanilla factory dot create topping, which means now the factory class, the specific factory class, vanilla factory or chocolate factory, has two responsibilities. One is to create the ice cream, and second is to add the topping. Now the factory class, in the factory method, when we saw, we were seeing that the factory was only concerned about making the ice cream. Now the factory class is not just making the ice cream, it is also adding the topping. So when it is adding the topping and making the ice cream, now two responsibilities of the factory class. So after all of that is done, this is the final place where it is being executed, where we are saying making ice cream, then vanilla ice cream dot make, which will print making vanilla ice cream, vanilla topping dot add, which will say whatever topping we are adding over here, and then we are printing it. So when I say vanilla topping dot add, if we go back to the ice cream factory class over here, when I'm saying create topping, okay, create topping, when I'm in the vanilla ice cream factory, create topping. So with vanilla, the topping which is created is sprinkles. So when this method is called, right, vanilla factory dot create topping, this is going to return me sprinkles. So vanilla topping will be sprinkles. Now when I'm doing vanilla topping dot add, so when it is creating the vanilla ice cream, for a topping it is adding sprinkles. Similarly, now for chocolate factory, if I go back to the factory class, I am returning hot fudge as the topping. So when I am doing topping, chocolate topping dot add, over here the hot fudge as a topping is being returned. So this is going to be the final client code. So what are the level of abstraction that we can see? Again, the factory classes per flavor is different. The toppings per flavor is different. So that is why again and again we are saying it is adding a deeper level of abstraction in the abstract factory class. We started with a very simple factory. where we were passing in the flavors, toppings and everything. Then we started to abstract out the flavor and create separate classes, vanilla ice cream, strawberry ice cream, based on the flavor classes. And now not just the flavor, even the topping is abstracted out. So now the topping can also be supplied as a interface it is created, and whatever topping you want to add, you just hard bind it with your factory class. Like we can see over here, the ice cream factory, when it is manufacturing vanilla ice cream, it is manufacturing vanilla ice cream plus it is manufacturing the topping of sprinkles. For chocolate ice cream, it is saying it will manufacture chocolate ice cream and also the hot fudge as the topping. For strawberry, it is doing strawberry ice cream and strawberry syrup as the topping. So now the responsibilities of the factory class, or the factory, concrete classes of factory, has increased. So that is why abstract factory method pattern is going to be the most complex patterns among the factory design pattern, because of the highest level of abstraction that it is achieving. Now moving on, we saw this example of ice cream, but what are the real world scenarios in software engineering where the factory pattern can be used? So when we use databases, we know that there are so many types of databases. There are NoSQL databases or SQL databases. Even SQL databases are of so many types. Now, when I want to say that whatever, okay, so today I am creating a database, I'm using MySQL. Tomorrow I want to migrate to a MongoDB database. So if I'm doing a database migration, if I have hard coded the database connection strings and all the related config values, I have to change the entire code. But if I make sure that there is a database connection factory which is going to take care of what database it has to connect to based on the user input, then it is so much seamless. So that is what is said over here, that the factory will create the appropriate database connection object based on the configuration or like user input, without exposing the implementation details of the database connection to the client. The client need not be worried whether the data is getting stored in MySQL or it is getting stored in Oracle or in MongoDB or in AWS DynamoDB. It doesn't care. All it cares is the data is getting stored, it is being persisted. That is why the factory class or the factory interface, whatever the pattern we will use, that will be concerned about making sure that the database connections that it is creating, it is embedded within the factory class itself and it is not exposed to the client. So that is one example. Secondly, logging. So what does logging means? Whenever we write any code, we want to make sure, like we do system.out.println, right? But in production code, we don't print out anything. What we do is we log it. Log is a way to get a trace of whatever has happened throughout your application. So when we do logging, it can be in different formats. Somebody will try to do it in XML data format, or they can do it in JSON, plain text, whatever. So in here also there will be factory class that will be creating the logging object based on the configuration, and then this will make the logging code more flexible, because today I am trying to print my logs in JSON because that is what is going to be used in my other monitoring graphs. Tomorrow if I want to change my monitoring tool which only accepts XML, so I will try to log the data in XML format. Today I am logging in JSON, tomorrow I log in XML. So if I am doing that switch, the factory class is going to make the switch from what logging object it is creating. So that will be the concern of the factory class and not the client code. So that is about the real world use cases of this pattern. So as I told, there will be a practice problem towards the end which you guys can solve to master your understanding of this pattern. So here's the problem that we have. It's related to games and weapons. So you have to create a weapon creation system using the factory pattern, and there are 3 types of weapon that is given: pistol, shotgun and sniper. And then every weapon will have certain characteristics like damage, the range, the speed and the type of ammunition. Okay, like for example, pistol can have bullets as its ammunition. So what we have to do for this is we have to make, in simple words, a weapon factory, weapon creation factory basically, where all the weapons will be created based on the attributes they have. So you have to use factory pattern to create the different types of weapons. Do let me know in the comments if you want me to cover the code of this in some other video. So now we are going to have a quiz. The first question is, which of the following is the benefit of using the factory pattern? It makes it easy to add new products without modifying existing code. It simplifies the creation of complex objects. It promotes loose coupling between objects, or all of the above. So you can answer the quiz questions. So you can give the answers to the questions of the quiz in the comments below. Then the second question is, in the factory pattern, the client code calls the factory method to create objects or instantiates object directly, implements the abstract factory interface, and option D is none of the above. The next question, which of the following design patterns is most suitable for creating objects that require complex initialization? Factory method, abstract factory, builder, or singleton? So with that, we are going to wrap up today's session. Thank you so much for watching the video. Hope you guys found it informative and useful. And if you did, please consider giving a thumbs up and do subscribe to the channel for more content like this. Thank you again. See you in the next video.